Hello everyone, welcome to Math World. Today we are going to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 1 for October-November 2019, and the code is 9709/61. So let's get started. Okay, so for question number 1, when Shona goes to college, she either catches the bus with probability 0.8 or she cycles with probability of 0.2. If she catches the bus, the probability that she is late is 0.4, and if she cycles, the probability that she is late is x. Okay, now the probability that Shona is not late for college on a randomly chosen day is 0.63. Find the value of x. Okay, so for this, I will show the tree diagram first. This is bus, and this is cycle. Okay, so the bus is with probability of 0.8. Cycling will be 0.2. If she catches a bus, then she will be late for 0.4 probabilities. So this is late. This is not late. So 0.4. So it means that not late, it will be 0.6. Now, if she cycles, the probability that she is late is x. So late is x. Then not late, because we know that total probability is 1. So probability of not late if she cycles is 1 minus x. Again, now it's given that she is not late. So P not late is 0.63. Okay, so this not late may be because of the bus or maybe because of she cycles. So now it will be 0.8 times 0.6 or 0.2 times 1 minus x. That is 0.63. Okay, so from here, 0.8 times 0.6, that is 0.48. And then you times 0.2 into the brackets. That is going to be 0.2 minus 0.2x. Then equals to 0.63. Now our purpose is to get the x, which means now here, I will move this negative 0.2x to one side and 0.63 to the other side. And then I rearrange 0.2x equals to 0.48 plus 0.2 minus 0.63. This is going to be 0.05. At last, your x is 0.05 divided by 0.2. That is going to be 0.25. So that is the solution of question number 1. Question 2. Anna has designed a new logo for a sportswear company. A survey of a large number of customers found that 42% of customers rated the logo as good. Now, first part, a random sample of 10 customers is chosen. What is the probability that fewer than 8 rated the logo as good? So, the number of customers means that this is discrete random variable. Okay, therefore it is binomial distributed. So now our distribution is n is 10. Rated as good is with probability of 0.42 because 42%. So from here I will say P is 0.42 and then the Q is going to be 1 minus 0.42. That is going to be 0.58. Now, for your information, when x is binomial distributed with NP, the probability of x equals to NCX, PX, QN minus x. Okay, then from here, it's mentioned fewer than 8. So PX less than 8. And then one more thing is, for the binomial distribution, your x starting from 0, then ends with n. So fewer than 8 means it will be 0 until 7. So it involves a lot of calculations. I can say I will calculate from 8 onwards, right? Because less than 8 means up to 7. So I minus 8, 9, and 10. Because there are 10 customers there. So this is a complementation rule. So and then apply the formula. This is going to be 10C8 P power 8, and then the Q power 2 because 2 failures. And then 10C9, 0.42 degree 9, 0.58 degree 1, plus with 0.58 degree, 10 successors, x equals to 10. So it will be 0.42 degree 10. Okay, so when you calculate all these values inside the brackets, it will be 0.017187. Now here, where I minus the value from 1, that is going to be 0.9828, and round up the value, that is going to be 0.983. So that's the solution for A, first part. Now second part, on another occasion, a random sample of n customers of the company is chosen. Find the smallest n for which the probability that at least one person rated the logo as good is greater than 0.005. That means now your x is binomial distributed. Now no longer 10 customers, it will be n customers. And the probability of rated the logo as good remains the same, 42%. 0.42. Okay, and now here probability, so P, your x is actually number of customers who rated the logo as good, at least 1%, so x greater equals to 1, and the probability is greater than 0.995, so greater than 0.995. So now here, at least 1 means 1 until n. Okay, so then I will just say it will be 1 minus the previous value. So less than 1 means it will be 0. So 1 minus px equals to 0, and it's greater than 0.995. So from here, I will say that 1 minus when x equals to 0 means that no success. So if no success, again here, p is 0.42, and then the q is 0.58. That means it will be all failures. N failures here. And it's greater than 0.995. Okay, so negative of 0.58 degree n is greater than, then 1 move to the other side. So 0.995 minus 1, that is going to be negative 0.005. So now I can divide the whole inequality by negative 1 to cancel off the negative 1. But remember, when you solve inequality, when you divide or times by a negative value, you need to change the inequality sign. That means this becomes 0.58 to the power n is less than 0.005. Okay, and now to get the n, since the n is a power of 0.58, then we have to take log both sides. So here, I will take log both sides. So this LG is basically the log with base 10. Okay, and then we have a formula over here. Log a power b, this is b log a. So whenever you see the power, you can just move it down. Alright, so that means here, it will be n log 0.58 less than log 0.005. Now, one more thing is, you need to calculate the log 0.58, and you will find that this is negative value. Do not move to the other side first, because if you move, means that you divide by a negative value. Then you will be missing the process of changing the inequality sign. Okay, and again, I divide by a negative value. So remember, we need to change the inequality sign. So it will be 2.301030 over negative of 0.23657. So that means now here, your n is greater than 9.727. Okay. So when n greater than 727, that means now remember, your n is the number of customers. Therefore, the least, you need to find smallest n. So here, I will just write the smallest n. It will be 10. So done for this question. Question number 3. The mean and standard deviation of 20 values of x are 60 and 4. So this is the mean. This is the standard deviation. Now, first part, find the values of summation x and summation x squared. So we know that mean is summation x over n. So the n is 20. Okay, so 60. That means from here, I need to find summation x. Then I will say summation x is basically n x bar. That is going to be 20 times 60. Then you will get 1,200. Now, for the s, right, our formula is s. Okay, I will say s or sigma, right? Because s is for sample. So here I will write sigma. Sigma squared is basically summation x squared over n minus mean squared. This is the formula. So then from here, just replace the values. 4 squared equals to summation x squared is unknown. The n is 20. Then the mean is given 60. Right? So now from here, just move this negative 60 squared to the other side. That means I will be getting summation x squared over 20 equals to 4 squared plus 60 squared. Then you will be getting 16 plus 3,600. Okay, and then summation x squared just multiply by 20. So 20 times the total here is 3616. So probably I will just write this is 3616 first. So therefore, summation x squared, it will be 20 times 3616, and you will be getting 72320. So that's the summation x and summation x squared values. Another 10 values of x are such that their sum is 550 and their sum of squares is 40,500. So now find the mean and standard deviation of all 30 values. Okay, so now, just now, your mean, okay, just now your summation x 1,200. So just now when n equals to 20, summation x is 1,200. Summation x squared equals to 72320. Okay, now additional n, this is 550 and 40500. So now, okay, this is x, right? So probably I just write x. So now from here, I will say my total x, it will be 1200 plus 550. That is going to be 1750. Okay, so now my mean equals to 1750 over 30. This is going to be 175 over 3, or you round up, that is 58.3. Now, for the summation x squared, okay, probably this is x, right? That is going to be 72320 plus 40,500, and this is going to be 11282. So now my variance, or the question asking for standard deviation. So standard deviation, that is square root of the new sum. Okay, the new sum squared. So 11282 over the n is 30 now, minus the new mean. So the new mean is basically 175 over 3. Then I square it. And now here, you will be getting 3221 over 9. And at last, the answer is 18.9. So that is a new standard deviation and new mean. Okay, question 4. You are given this probability distribution of x, find the p. So we know that total probabilities is 1. Therefore, 1 over 4 plus p, just add all these probabilities and let it be 1. So here I will be getting 6p plus 5 over 8 equals to 1. That means 6p is 3 over 8. Hence, your p is 3 over 8 times 1 over 6. So the 3 and 6 can be simplified. This is 2. So you get 1 over 16. Okay, done for the first part. Now, find EX and variance X. So I will change my P into 1 over 16 now. So the EX is basically summation X. Okay, so EX is basically summation X times P. So that means now you need to times the X with the P before you get the sum. Just multiply all this. So minus 1 times 1 over 4. The 0 can be ignored. No need to calculate. Okay, then 1 times P. So your P is 1 over 16. So 1 times 1 over 16 plus 2 times 3 over 8. Then plus 4 times 4P. So 4 times 4P. Okay, now your P is 1 over 16. So 4P means 4 over 16. That means now here you will be getting 25 over 16. That is your EX. Before we get the variance X, we need to calculate EX squared. So EX squared means now you need to square all the X. This is a definition. So you square the X, minus 1 change to minus 1 squared, then remains the probability. 1 change to 1 squared, multiply with the probability, 2 change to 2 squared, then probability, and lastly 4 squared. Okay, then now when you calculate this, that is going to be 93 over 16. So your variance X is EX squared minus square of EX. That is going to be 93 over 16 minus EX is 25 over 16. So minus 25 over 16 squared. Then from here, you will be getting 863 over 256. So that's the variance calculation. Okay, part 3. Given that X is greater than 0, find the probability that X is equal to 2. Okay, now your probability that X is greater than 2. And now, given that, don't forget this, given that means conditional probability. So that means you are counting P, X equals to 2, given that X is greater than 0. So here is basically when you refer to the conditional probability formula, PA slash B, that is PA intersects B over PB. So from here, I will say that this is basically probability that X equals to 2, given that or N intersects X is greater than 0 over Px greater than 0. So now, Px equals to 2 intersect with Px greater than 0. Actually, the intersection is Px equals to 2. Then over Px greater than 0. So refer to the table, Px equals to 2, the probability. Px equals to 2, probability is 3 over 8. So here I will write 3 over 8 over Px greater than 0. Px equals to 0 means that it will be Px equals to 1, 2, and 4. So go back to the table. Px equals to 1, that is P. Okay, so now means that the denominator will be just addition of these three values. And replace a P by 1 over 16. So I will be getting 1 over 16 plus 3 over 8 plus 4 over 16. Okay, then from here, you will be getting 3 over 8 divided by 11 over 16. And at last, you will be getting 6 over 11. Okay, so that is the solution of this question. Now, number 5, Ransha measured the length in centimeters of 160 palm leaves. His results are illustrated in the cumulative frequency graph below. Okay, so now this is a graph. First part, estimate how many leaves have a length between 14 and 24 centimeters. Okay, so the length, look at here, 10 squares, 5 units. That means each square is 0.5 units. Now I need to get 14. 14 means here. Okay, then read how many leaves. That is 58. Right? So, oh sorry, it's not 58. Okay, here 20 units for 5 squares. So each square is 4 units. So that means here is you minus 4 from 60. That is 50 56. Right? So let me check again. Okay, then now here, when it is 24 centimeters, so remember this is 0.5 units per square, right? That means 24 is 2 squares before the 25. Here is 24. This is 14. Okay, when you refer to the graph, actually it is not exactly uh, 156, right? Probably when you okay, so when you see clearly, this is 156, right? So you just draw the dotted line. Here is 156. Okay. So let's check the other one. Okay, when you look at this value carefully, right? If let's say I enlarge it, so it is not really touching the 56. It is a bit lower than that, right? Probably when you refer to here, it is a bit lower. So it means that somewhere here. Alright, therefore I can say that it is roughly 55. Okay, it is close to 56. So from here, I will say that the number of leaves will be 156 minus 55. So here, 156 minus 55, that is going to be 99. Okay, so this is how we solve this question. Okay, now part 2, 10% of the leaves have length L centimeters or more. Because of or more, that means this is upper, right? Upper 10%. So estimate the value of L. So this 10% is the upper 10%, which is the top 10%. So I will say 100% minus 10% over 100%, right? Or probably I will just write 100% minus 10%, that is 90%. So now it's 90% of the total. So the total here is, look at the graph, it's up to 160. Okay, so it means that 90% of 160, that is 160 or 0.9 times 160, then that is going to be 144. Okay, this will be the 10%, top 10%. All right, now I need to find what is the L. So now you check 144. 144 is basically here. Then this is the number of leaves. Now this is the length. Okay, and each square is 0.5. There are 4 squares, that means this is 22. Okay, so here I will just write this is the L is 22 because the 10% is L centimeters or more. That is a 10%. That's why we are referring to 90% of the total. Okay, now part 3, estimate the median and interquartile range of the lengths. Now, median is the position. Okay, the position of median is half of the total, that is theta number 80th, right? So now you see 80. So 80, it would be here. 80. Okay, then it is in the middle. So 1 square is 0.5. That means this is the in between first and second, right? Therefore, I would say that this is probably 15.6, right? So here I will say 15.6. They will be given a range. Marking scheme accept a range of the value, right? So here I will say 15.6. Or you can say it is in the middle, so 15.7 also doesn't matter. Right? So now that is my median. Then my interquartile range, I need to get my Q1. Q1 is 1/4 of 160. That is going to be 40th. Right? So now here, let me check whether it's correct or not. It is in the middle, probably middle of that. I will say 15.7, and then it will be more accurate. Okay, because it's in the middle. So 15.7 for the mean, for the median. Sorry, for the median. Now, the 40th theta refer to the graph. 40th is here. Okay, again, it is in between. So that means that is 10.11, 12, maybe 12.5 is here. Then in the middle, then you can say 12.7. So this is 12.7 Q1. So 12.7. Then your Q3, that is 3/4 of the total. So you times 3 to 40, that is 120. So read 120. 120 is over here. And again is in the middle. Right, so this is 15. That means here is 19, right? 19, so probably this is 18.7. This is Q3. So I will write Q3 is 18.7. Therefore, your interquartile range IQR equals to Q3 minus Q1. That is 18.7 minus 12.7. Here I get 6. Okay, now Sharon measured the length in centimeters of 160 palm leaves of a different type. He drew a box and plots box and whisker plot for the data as shown on the grid below. Compare the central tendency and spread of the two sets of data. Basically, central tendency is referring to median. In this case, spread is referring to the interquartile range, IQR. So now, for Sharim, okay, the median, this is Q1, Q2, Q3. The Q2 is actually the median. So median equals to, okay, now here 5 units for 10 squares. That means each one is 0.5. So here is 11, 12. Okay, so the median is 12. And then the Q1 is exactly 10. And then Q3, the quarter, is exactly 20. Okay, so now I compare with the previous values. So median 15.7, right? 15.7. Now median is 12. That means Sharim has less median. And then the IQR, interquartile range, previous data was 6. And now this is IQR. Okay, now I need to calculate the interquartile range. That is 20 minus 10. That is 10. Alright, so now I will say higher median for Ransha. Okay, higher median for Ransha. And the IQR, interquartile range for Sharim, is 10. But the interquartile range for Ransha is only 6. So lower IQR, interquartile range. I say lower spread or less spread. Okay, less spread, because the spread is measured by the interquartile range. Less spread for Ransha. Alright, so that's all for the comparison. Now number 6, find the number of different ways in which all 12 letters of the word, okay, this is a word, can be arranged so that all 4 E's are together. So basically, STEEP, LECHASE. So there are 12 letters here. I have 2S, okay, 2S, and then I have 4 E's. 4 E's. And then the rest of them are not repetition. So that means here, so here is 6. That means I have 6 others. Okay, now 4 E's are together. So when 4 E's are together, group them as 1. Okay, then here you still have 8. But out of 8, we still have 2S. Okay, so remember, your E's not necessary to be the first one. It can be any way. That means 1 plus 8, it will be 9. You are arranging these 9 letters. So now my number of arrangements is basically I'm arranging 9 letters, so 9 factorial. But out of 9 letters, you see, out of the 4 letters, right, it will be 2S, so 2 factorial. Now for the 4 E's, since they are all together already, so we treat this as 1, and there's no difference among the 4 E's. Therefore, your working is just 9 factorial over 2 factorial. That is 181440. Okay, we do not need to consider the E's because we are treating them as 1 letter. Now part 2, find the number of different ways in which all 12 letters can be arranged so that S are not next to each other. Okay, so when S are not next to each other, I will say that number of arrangements equals to number of arrangements without restriction minus number of arrangements when two S are together. Because when you observe the two S, either they are together or they are not next to each other. Okay? So now, number of arrangements without restriction means that you are arranging all 12 letters. But out of 12, remember, we have two S and 4 E's. So minus when the two E's are together. That means now two E's or two S are together. That means here you still have 10 letters. So that total is 12 letters. But out of the 10, you have 4 E's. So now at first when you arrange, you are arranging 2S, you treat 2S as 1 and then plus with the 10. That means you are arranging 11 letters. Okay, so the number of arrangements now becomes 11 factorial. Then since you treat 2S as 1, now you have to consider the 4 E's, the repeating E's. So divide by 4 factorial. Okay, then now here you will be getting 9979,200 minus 166,3200. Then at last you will be getting 8316,000. That is the number of arrangements that satisfy this condition. Okay, now 4 letters are selected from 12 letters from the word. Find the number of different selections, no more arrangements, if the 4 letters include exactly one S. So now here, S-T-E-E-P. Okay, basically here I will say that I have 12 letters. Out of 12 letters, there are 4 E's, then 2 S, and 6 others. Okay. Now I go back to the previous question. Basically here we have another method, right? So now, or you can just say, instead of using this method to solve the question, I will say that if the two S are not together, I will be arranging all other letters first except the two S. So that means you will see here, right? At first you are given this. We have two methods to solve this question. Okay, your initial word will be this, C-H-A-S-E. Now, if I want to make sure that the two S are not together, I will arrange the rest. Okay, so then here, basically there are 10 letters, therefore 10 factorials. 10 factorial. But also 10 factorials, you have 4 E's. So divide by 4 factorials first. And then followed by arranging the 2S. Okay, so for the 2S, I have all these possible positions. Okay, so as long as I assign the S to any of the arrows here, then the S will be not next to each other. So just count the number of arrows. You have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So out of 11 letters, okay, the orange color is for the S. Now out of 11 positions, I need 2. And then there's no difference between the 2S, so it means that I just need to choose any 2 positions. Okay, so wait, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 positions for the S. So it should be 11, choose 2. But if there is a difference between the two S, then you should use 11P2. So with this, you will be getting the same answer. Okay, so we have 2 methods to solve this question. Now go back to this part 3. Find the number of different selections if 4 letters include exactly one S. So from here, you need to choose 4. Out of 4 letters, only one S. Then the rest can be any numbers, any letters. So probably I can say 1S, 0E. Okay, so 1S 0E means that I have to choose 3 others. So, alright, then probably I can have 1S and then I have 1E. So probably I will write like this, because the question just says selection. So 1S, 1E, then I choose 2 others. Probably I have 1S, 2 E's, then 1 others, and then 1S, 3 E's. Okay, so the number of selections. Now, all these will be others. I have 6 others, 6 other letters. Therefore, I just need to choose 3 for the first case from 6. That is 6 choose 3. 6C3. Or all is plus because all these are all. I have chosen 2 letters, 1S, 1E. So I need 2 more. So the 2 more will be chosen from the 6 others. Therefore, 6C2. Or I need 1 more, 6C1. And the last one is I have chosen this 1S and 4Es, and 3Es. One case or one way to do it. Therefore, you will be getting 20 plus 15 plus 6 plus 1. At last, you will be getting 42. So that's the number of different selections. Okay, question 7. The shortest time recorded by an athlete in an 400 meters race is called their personal best, PB. The PBs of the athletes in a large athletics club are normally distributed with mean 49.2 seconds and standard deviation 2.8 seconds. First part, find the probability that a randomly chosen athlete from this club has a PB between 46 and 53. So from here I will say X is normally distributed, mean is 49.2, standard deviation is 2.8, so the variance is 2.8 squared. Now the probability is P between 46 and 53. Now, if your X is normally distributed with mean mu, variance sigma squared, when we standardize it, it will be X minus mu over sigma. So now I need to standardize this. So this will be 46 minus 49.2 over 2.8 less than Z less than 53 minus 49.2 over 2.8. Then here you will be getting the values of negative 1.143 and 1.357. So now here, when I sketch the graph, one is negative 1.143, another one is 1.357. So to find this probability, remember we always use the graph, alright? So I will say that is this probability minus the smaller probability. That means this is P Z less than 1.357 minus P Z less than negative 1.143. But the negative value, I need to draw another graph. This probability, negative 1.143, since the critical value, right, is negative, therefore I flip to the right side. And the region will be the orange region. So now to get the orange region is basically total probabilities minus PZ less than 1.143. So then I will have to change to that form before I use the table. So with this, you can just read the table. That is going to be 0.9126 minus 1 minus 0.8735. Then I will be getting 0.7861 and round up to 3 significant figures. That is going to be 0.786. So that's the solution of this question. Part 2. It is found that 92% of athletes from this club has PBs of more than t seconds. Find the value of t. So now Px greater than t is 0.92. So now again you standardize it. It will be PZ more than T minus. Okay, the mean remains as 49.2, variance is 2.8 squared. So minus 49.2 over 2.8. That is greater than, is equals to 0.92. Then now here I need to decide where is my value, where is my line here. Now when it is greater than 0, PZ greater than 0, that is only 0.5. But then now greater than the line is 0.92. That means the line should be on the left side, so that you will have bigger region. So this is my T minus 49.2 over 2.8. Okay, and then now I need to flip to the other side so that it is positive value, because obviously the line is on the left side. So now once you flip, the region will be flipped. This is 0.92, and then we need to times a negative to make it to positive value for the line, critical line. Okay, so that means from here I will say PZ less than negative of T minus 49.2 over 2.8 is 0.92. And now I can get the value from the table. So from table, PZ less than 1.406 is 0.92. So now when you compare these two equations, obviously they are the same for the highlighted values. Okay, so now I will equate them. So negative of T minus 49.2 over 2.8, that is 1.406. Then now this negative can be combined with 2.8 and move to the other side. So now here I will be getting T minus 49.2 equals to negative 2.8 times 1.406. Then you will be getting negative 3.9368. And at last, your T is negative 3.9368 plus 49.2. That is going to be 45.3. Okay, that is your T value. Now, 3 athletes from the club are chosen as random. Part 3, find the probability that exactly 2 have PBs of less than 46. So means that now, firstly, I have to find less than 46 seconds. What is the probability? Then from there, I consider 3 athletes and exactly 2 with that. That means firstly, I find the probability using normal distribution, then followed by the binomial distribution. Okay, so now again, Px less than 46, it will be Pz less than 46 minus 49.2 over 2.8. You standardize it. Then this is going to be Pz less than negative 1.143. And now you sketch a graph. So negative 1.143 is on the left side, and the region is on the left side as well. So because of the region is on the left side, now we flip it. It will be 1.143 on the right side. Okay, it will be symmetrical. Then now from here, I will say that the orange region is basically 1 minus all the previous probabilities. So from here, that is going to be 1 minus Pz less than 1.143. And now read the probability from the table. That is going to be 0.8735. And now here you will be getting 0.1265. Okay, now use this probability and put it in the binomial, because now it is considering the athletes. Okay, your x is actually the PBs, it's different. So now I will say my y is binomial distributed. The mean is 3, the n is 3 because 3 athletes are in the consideration. And then the probability of having less than 46 seconds will be 0.1265. That means now the P is 0.1265, and then the Q is going to be 1 minus 0.1265. That is going to be 0.8735. Okay, and now it's mentioned that exactly 2 have this PBs. So it means that now exactly 2 means PY equals to 2. So when PY equals to 2, this is 3C2, that is a binomial distribution. So X is binomial distributed, and P, probability of cap X equals to X, that is NCX, PX, QN minus X, where the X start from 0 until N. So that's why I'm getting 3C2 here. Then the P is 0.1265 degree 2. And then the Q is 0.8735. Then degree 1. So at last, you will be getting 0.0419. So that is your probability of, out of 3%, 3 athletes, only 2, exactly 2 have less than 46 PB, 46 S. Okay, 46 seconds. Okay, so with this, I have completed the whole paper and also comes to the end of the video. Thanks for watching. Please subscribe to the channel and share this channel with your friends if you enjoy watching my videos. So, and also stay tuned for more upcoming videos. Thank you for your support. Bye.